right, so it looks like I went easy on you guys, and we're only going to look at one example here. So remember, in order to graph these linear inequalities, I need to make sure that y is isolated first. I can see that I already have one equation that y is isolated for, which is great, makes my life easier. That's what I'm going to start with. So I'm going to label this equation B, and I'm going to go ahead and graph that. Excuse me. I have a y-intercept of 7, so I'm starting up at 7. 1, 2, 3, 4, 5, 6, 7. And I have a slope of -2, or -2 over 1. So I'm going to be going down 2 over 1, down 2 over 1. Remember, it's going to be super important with your graphing requirements that you're taking up the entire grid. Because I have an or equal to, I'm going to be getting a solid line. That's what that tells me. So make sure you are using a ruler to make nice, straight, beautiful lines. I'll label this B. And now I got to do my shading. That inequality reads less than or equal to. So where on my graph do the y's get less than this line? And that would be underneath it. Because you're going to be putting 2 of these on here, you really want to make sure that you're not just scribbling it in, because you're going to need to be able to tell the difference between one shadings for one line and then the shadings for the other line. All right, so now let's take a look at this line A, or this first line that they're giving us. And let's use purple. Here, I can see that y is not isolated. I need to solve for y first. And I'm going to do that by dividing each piece by that -2, because that's what's preventing y from being alone. Remember, when I'm doing this dividing by -2, I'm going to need to flip my inequality. So that's going to leave me with y is not greater than anymore, not less than anymore, but flipping to greater than. 2 divided by -2 is just -1 x. 2 divided by -2 is a positive 1. All right, so now I've got a y-intercept of +1, and this is why you don't want to scribble in the shading. Otherwise, I'd be trying to plot points on something that I scribbled in. And I have a slope of down 1 over 1. So down 1 over 1. We can see we've got an intersection point. Up 1 over 1. And because of our inequality here, we know this one does not have a line over it, so it's going to get a dashed line. So I'm just going to kind of chill, connect the dots. Dashed line. Boom sauce. And last but not least, my shading. This one is saying greater than. Make sure you use your hands. If it makes the L, it's less than. This one does not make an L, so it's greater than. So I'm shading above the purple line. Okay. And you can see that the shadings overlap in this area right here. This is where my red shadings overlap with my purple ones. But notice, if I had a point, let's talk about this. Well, here we go. First, let me label that graph A. And don't forget your S for solution set. Actually, let's use black instead. That'll show up better. There we go. And so part B wants to know, is the point 6, -5 in the solution set? We'll look at that later.